Welcome to the final, fastest video in the West about the volume of the last major solid we need to talk about, which is the volume of a sphere. This video will be the fastest of all the videos so far because the volume of a sphere is actually a very, very straightforward formula. Goodness gracious, can't speak today. So before we jump in, we need to define what a sphere is, and I probably don't need to define it for you in terms of you knowing what it looks like visually, but to give you a more textbook definition, a sphere is what we use to describe the set of all points in space that are equidistant, equal distance, from a given point called the center. In other words, just like a circle has points equidistant from a center point, a sphere is the exact same thing, it's just the three-dimensional version of that. And just like in a circle, the radius is the segment from the center to the edge of the circle. You could also, or of the sphere, sorry. You could also say the surface of the sphere if you would prefer, in this case. And the diameter is the segment from one point on the surface to, and I'm not going to say I'm going to say to another on opposite side, passing through the center. So that's our diameter, which makes sense. And the only reason we have to be clear that we're talking about passing through the center is because in three-dimensional space, we could theoretically travel from this point to this point and say, hey, look, I traveled to the opposite side. And we really haven't gone all the way across. We need to go basically straight across the sphere in order to truly find a diameter. Now, a couple other kind of silly terms that you'll probably never hear again, if I'm being completely honest with you, is that of a great circle. It's any circle that contains a diameter of the sphere. In other words, it's directly around the center of your sphere. So this would be an example of a great circle, whereas this slice up here at the top is not a great circle because, again, I'm not containing one of the diameters of the circle, or of the sphere. So that's the term for a great circle. And again, circumference, the circumference of the sphere, or sorry, the circumference of our great circle is the same thing as the circumference of the sphere. In other words, all we're saying is that we need to measure circumference around the widest part of a sphere. And then last but not least on circles, hemispheres are two half spheres created by the great circle. Again, a great circle would break this thing up, would break this sphere up into two sections, one on top and one on bottom, which we'll call hemispheres. Now, there isn't space on here for this volume of a sphere formula in these notes, which is insane, because it's very important. What is it? Well, it's actually kind of a weird formula. The volume of a sphere is 4/3 pi r cubed. So again, it's definitely going to be units cubed, and in fact, it ends up being a radius cubed to find volume, because we're in 3 dimensions. But that one formula is all we need in order to find the volume of a sphere. And you'll notice the problems go really fast because all I need to know is a radius. Notice here I'm given a diameter of 18, which means a radius of 9. So the volume is 4/3 pi times 9 cubed. And just like that, I'm good to go. So I do 9 cubed times 4/3, I get 972 pi feet cubed. Boom. Dunzo. There's my volume. Notice I could be given information that doesn't directly tell me the radius, but in almost every situation, finding the radius is going to be easy. So for example, notice here, someone tells me the circumference is 13 centimeters. Well, all I need to remember is that circumference comes from pi times diameter. Or also, circumference is 2 pi times the radius. Well, what do I know? Well, I know that the circumference is 13. So 13 is 2 pi times the radius. Well, now I can divide both sides by 2 pi in order to find my final answer, which in this case tells me that my radius is about 2.07. Now that I have the radius, I can plug that into my formula, which is 4/3 pi times radius cubed. So I'll do radius cubed times 4/3 times pi. And since I already have horrible decimals, I'm just going to multiply it all the way out. And I get that the volume is about 37.10 centimeters cubed. Done. Again, the volume of a sphere relies on the same consistent formula again and again. Now, the only way that things can get more complicated, and this is more of just a proof of concept, you're not going to have to do any of these yourself, but is if somebody had you find what's called a composite space, which is a figure that is three-dimensional that's a combination of multiple figures. Okay? And in these situations, what we would have to do is we would have to find the volume of the pieces. Now, I'm not going to do this whole process with you, but I'm going to talk you through what it would look like. For example, if I look at this backpack here, what I'll notice is that it's really just a half cylinder on the top, right? Like half a can, on top of a prism on the bottom, a box. So if I wanted to find the volume of the backpack, I would just do a really involved problem where I would find half the volume of the cylinder, and I would add to it the volume of the bottom box. And that would be it. And again, my process for doing that might be a little bit involved. I'd have to find the radius of my circular cylinder base up here and then multiply that by how thick it is right there. And then I'd also have to find the dimensions for this bottom solid, but none of that is well, it's just a lot of steps. Notice this also can apply to something like an ice cream cone problem. We might have a situation like this where someone tells us the height of an ice cream cone. They say it's 7 centimeters, so here's our little ice cream cone. And then they also tell us that it is 4 centimeters in diameter, so in other words, it's 2 centimeters in radius. And then it might say, hey, we've got this scoop of ice cream, which is a sphere, of course, and it has a diameter of 15 centimeters, which first off, if you haven't realized, is insane because your cone is only 4 centimeters wide. But ignoring that, we might say, well, how much ice cream can fit inside our ice cream cone, right? So maybe when we get our ice cream, they fill up the cone all the way and they put a big scoop on top. Well, how would we find the volume of all this? Well, the volume of our ice cream is then the volume of the cone plus the volume of the scoop on top. And again, the scoop would be a sphere, the cone would be a cone. We would find both of those volumes and add them together. And that's the heart of compound solids. So really, it's just finding multiple different volumes and adding them together. And that, folks, really is all we're going to talk about when it comes to volume. That's it. That's the entirety of it. You have your 5 major types. You have your spheres, you have your pyramids and cones, and you have your prisms and cylinders. But really, there's just 3 different things to keep in mind. Your prisms and cylinders are just your area of your base times your height. So too are your pyramids and cones, so long as you remember that there's a 1/3 scale factor in the front. And then your sphere is just 4/3 pi r cubed. That's all the volumes that we're going to focus on in this unit. So congratulations, you've finished week 5 of Continuing Ed, and you've learned everything there is to know about volume. Thanks so much.